Hello everyone, welcome to another stream. How's it going? So, last stream we started work on PBR, materials, bringing those in, and we've got something working, but there are bugs. I'm not sure if the specular here is a bit too small, or not, and the metalness doesn't work at the moment. So what we're going to do is we're going to plug in we're going to get rid of this UI and put another one in, which is to do with changing the PBR material values and the light as well. So we can change the values and see what is wrong. And also probably want to build something like, where are you at? The shader toy. This one. Where we can basically hold on a minute. Where we can basically see individual aspects of the lighting, say diffuse, specular, the normal distribution function, the Fresnel, and geometry, and just see how that contributes to the overall lighting or the scene. So we're going to start building that first. But before we work on that, I want to do another recap because I don't think the one I did the other day was good enough, and I'm combining it into a devlog. So I just want to start with that. But I hope everyone's doing well. Okay, so we've taken some of the code and put it into the code base and tweaked it a bit to get it working. So this is with metalness 0 and roughness 0. So we should be seeing something kind of plasticky. I'm kind of unsure about this specular thing. Maybe it should be a bit bigger in some cases, but yeah, I don't know. So what we want to do, wait, I think I want to take that again. Right, so we've gone on, we have, okay, so we've poured some of that code into the code base and actually got it up and running and working. So this is with roughness 0 and metalness 0 as well. What you'll notice is we are seeing a bit of specular here. This is a very, plasticky looking setup, basically. So it's kind of coming through, but I'm sure there's a bunch of issues. Like I tried to put metalness to 1 and there's an issue there. So what you're seeing here is the debug arrows. There's a light vector which is which is the longer one. The green one is the half vector, and the red one is the vector towards the camera. So it was using this to debug some stuff. So we've basically just ported the code over. It all seemed to work fine except for the normal distribution function. This one had to find another implementation and use that instead. So we're going to look into that today as well. Before I carry on, what I would like to do is basically port this type of system into the game where we can choose different viewing modes. So only view how much does the normal how much does this contribute to the main image, how much does the Fresnel, and how much does the geometry, and so we can debug when we change stuff like metalness or roughness and compare it to this one basically and see what we get, which would be nice. Cool, so let's build that now. So where we do the UI currently, we're just going to nuke that thing, and we're going to bring up the material and lights up to where we do that UI. So it's here. Drop it here somewhere. Yeah, so we'll comment this out. And then we're going to do some UI here. So albedo, we can skip emissive, roughness, metalness. We can make a couple of little functions, I reckon. Oh, what's intensity? No, it should be right. So let's just get the albedo working. So what we would like is to go from sRGB to linear, unpack from U32 material dot albedo. So I want to make these static so they're persistent. Shoot. I'll do. So now I have this. I want to do a piece of text. Right, window rectangle. Cut top. So we do a piece of text and then we'll do a slider underneath, I reckon. Well, I could do another cut. Do a B-rec. Sure. Let's do a cut left. So we cut left. Bit of text. Color. So of course albedo. Then what I would like to do is make us 4 sliders. So I guess we can say cut. Becoming 500 is a lot. Oh. So we can then just keep cutting A left and say slider. Slider. So we want a slider of float 30. Have I got yeah, I haven't really got it vectorized. That's okay. C.R min max 0 1 and the box style. So I think we can do this. GB. So if we try that for now, we've got to poke it back in though. So material dot albedo equal, and we do the reverse, right? So GPU linear to sRGB. C, and then we need to pack into one of those. Okay. Right, so we've got it right at the top of the screen. These are definitely a bit too big, but we're able to change the albedo here. There's the green channel changing. right? There's the red, green, blue rather. So that's good. That's happening. Although I should have cut 40 there. Maybe 30 then. Maybe it's 28. That works at least. Right, so the issue is it doesn't really... so we could probably have done 20. The problem is the text has a box around it. There is a no box style. So this doesn't have to be 300 anymore. It's probably be like 100. Maybe let's cut 30, see what happens. Yeah, it just stays up there. Yeah. See, the issue with the text is it's not centering. UI. Yeah, just puts it in the box. That's fair play. I can align it to the center and cut it based on the height of the text. Should be alright. Just put the box around it. Back at 30. Hey Chandu, how's it going? Yeah, PBR time. We've already got the adjustable albedo. So just plugging these boys in, boys and girls. Alright, so there's albedo. We want a roughness next. Oh, we can do emissive as well. How's it going, Chandu? You been up too much? Right, so there's emissive. That's done. Roughness. Roughness. I think it's just as simple as doing that. And voila. Metalness. And then was that it? Right, so that should be all the ones for the mesh. There's metalness. That's just showing the specular there. Okay, so it might be working. Roughness. It definitely glitches out at 0 though, that's bad. Emissive. Oh, interesting, it's making the lower side show now. That makes sense. A bit of emissive there. Albedo. Cool. Yeah, you definitely need like a cube map to make the metalness show well. I wonder if we can look into that today. We don't really have cube maps though. Shiny balls, yeah. Same time as normal, Dora. What's going on? Yeah. How you been? You been up so much? Alright, so let's make a little comment about that. Oh, I also want to change the light, isn't it? The light, color, and intensity. Color of the light, light color, and intensity. Right, that's legit. Yeah, I got my Pepsi. The wife went and brought some back today. It was just super nice. I actually haven't had it all week, so I've been a good boy. Been a good boy. Just a standard Pepsi though, Pepsi Max. Right, I think we got all the bells and whistles. Here, if you drop the red, it didn't matter. There's a bit of green there, and yeah, so cool. An intensity, it's not between 0 and 1. 0 and 50 or something, I don't know. Problem is it might be like, because it's in linear. What value is it at? Oh, 5. Let's do 25 then. Yeah, okay. Nice. Right. So I think we've got enough to play with now. And then we can figure out like what is wrong with wait. I ain't got enough to play with. What are we talking about? We want to be able to have a drop down and select only viewing a certain aspect of the PBR, like the stuff that's going on to do the PBR shading itself. So only view and diffuse, specular as a whole, or specular normal distribution, Fresnel, or geometry. Right. Let's record that. Alright, so we've got these little widgets in here, so we can change the albedo of the material for the spheres. So this is red, green, blue. Then we've got the emissive. So this obviously just changes the material as a whole, or the sphere as a whole, because it's just adding light to the whole thing, even the places which are outside of the range of the light. And then roughness, which makes the specular disappear a bit, which we can't really see because it's too bright. And then metalness, which only reflects specular light. And then the light color, change the light color. So we've got enough here to play around when it comes to the settings of these spheres and of the materials and the light. Those words are just too stumbly. Let's do that one more time. Right, so we've now got a bunch of these settings here. So we've got these four, which are for the material itself on the spheres. So we can change the albedo, which is like the base color, and this interacts with the light. So we've got red, green, blue. We've got emissive, which is added on because it's like light that's coming from the surface itself. So as you see, it's in the shaded area. It comes on. And then we also have roughness, as well. So this will change this will make if we can see it. Yeah, it shows that little specular highlight. And then as we get more rough, it goes. But if we put it fully 0, it disappears, and that's a bug we need to fix. And we've got this one here, metalness, which only reflects specular light. So I think we need like a cube map to make this look good. But yeah, we'll have to look at the bugs when we add the next widget, which allows us to view the individual things that make up the PBR shading itself. So just work on that one now. Cool, so we just need a drop down. Where's the combo boxes? We've got one somewhere. Here we go. Oh, that's a test. Yeah, this is good enough. Oh no, wait, there's a shorthand one. Yeah, where's the shorthand one? Here. I'm sure I'll figure it out. So in a combo box, let's do some more cuts. We don't really care about the changed aspect of it. So we'll put this in the shader global somewhere. So it'll be accessible to all the shaders and that easily accessible. So I need to put just a U32 somewhere. Oh, brilliant. U32. PBR view mode, and I guess we could have it as a. You know what? I could have done an enum. Yeah, I could have done an enum, but it's fine. Let's do an array. So we'll just have like the view modes, an array of those. So we want to view diffuse. So basically all. Diffuse. We also want to view specular, normal distribution function, Fresnel. I guess D, F, and G, as they call it, geometry. I guess I can shorten it. Geometry, Fresnel, normal distribution. So if these are all the view modes, we can pass all those in there, and we can have that PBR view mode, just like that. So it should, I guess it's going to be a very wide box. No, that's cool. It's just here. Nice. It says light intensity though. So we'll say view so we can view all, diffuse only, specular, normal, distribution. I'll just say so for now. Geometry. Maybe that fits on the screen, so we might as well just have it all in there proper. There we go, look at that. So we should be able to select those and change the viewing modes there. So we just got to pass that into the shader. So let's put that inside our massive globals data structure. This is just in a buffer somewhere, and it's just accessible with a nice macro. So we're just going to dump it in here. And we'll make sure that we actually set this value CPU side. So right, here we go, globals, this thing equal that thing. And there we go. So now in the shader code, we just have to do something similar where we say if so the cook torrents is the specular. So cook torrents, I can just call it specular actually, and then I can copy that and call it diffuse. Right, so we're specular and diffuse now. So basically the idea is if, I guess we just switch statement here. Switch PBR view mode. Case 0, 1, 2, 3, 4. I think we've got 5 options, right? If I remember anything. 6. There we go. So all is obviously this one. The next one is diffuse. So diffuse only just returns diffuse. The next one is normal distribution. Sorry, specular as a whole. So it's just specular. Then normal distribution function. So we should probably just manually do it. So that's normal distribution is ggx row bridge. This is one that gives you the specular highlight. That. So this one. So I guess we'll just copy paste it. Normal distribution for now. So we've already done the Fresnel here, it's KS, but we'll just do it again. And then the last one is Smith, so it's the geometry function, which tells you how much shadowing, how much of the rays is shadowed, or something like that. Yeah. Right, so now I've got those viewing modes all plugged in. They should. Where's my cook torrents? Specular. Rightio. More compile errors. Roughness. That's material. Dot roughness. Surface normal? No, half direction. Oh, this one's a float, isn't it? Fresnel's a float 3, Smith geometry is a float as well. Whoops. Specular. Specular. Yeah, very easy to say that, isn't it? All these correct terminologies. Yeah, we're going to try and get some of that maybe. We'll have to play around with different ones. Maybe we should focus on doing a cube map. But yeah, so now we can select diffuse. So this is the diffuse color. There's no specular on it. Specular only. That doesn't seem right, does it? There's normal distribution. That seems pretty nice, actually. So it seems like the shadowing function is a bit aggressive. So this alone is pretty cool. And the intensity is changing the size of this, right? Makes sense. Alright, I should probably press mark it down. But how's it going out, Kraz? How you been? Right, so we've got this like drop down here, so we change the viewing modes. You'll notice if we get up close now, we can change it to diffuse, so the specular contribution is now gone. We can change it to specular, only see the specular here. And it's a bit darker, maybe, I don't know, maybe this is wrong, but I'm not sure. We haven't really got a cube map or an environment map, so it's hard to maybe tell. If we change to the normal distribution function, what we see is this is nice and big. So maybe there's something else with probably the Fresnel just adds, I think. Wait, no, they all get multiplied together. So this is the Fresnel contribution. Then this geometry contribution is that. So I guess, yeah, we need to compare this with the shader toy that we've got open, and maybe we can have a play around with different implementations of these specular terms, if you will. Or maybe we should get a cube map in here so we get some more light from different places, basically. Right, that's good. I like that. So we can play around with things, and so you see the roughness. As it gets more rough, this gets bigger. But it's interesting. Oh, so I guess this gets bigger. The normal distribution does. But obviously it gets cancelled out by something like the geometry. The geometry, when it gets rougher, will get darker, right? No? Oh, my intuition. Probably the Fresnel, can it? Why aren't these responding to roughness? Yeah, that one makes sense. Well, that's weird. Good so far. Whole week free from work. Awesome. It's relaxing. Have you gone out anywhere? Zoom. Yeah, this is only if you're in the normal distribution component of it. But yeah, we get to compare how it is. So should we try and see if I can get a cube map in or an environment map? I don't know how much work that's going to be. The code isn't here. Because it's called like image-based lighting, isn't it? So environment specular color. BRDF approximate. Raises spherical harmonics. That's over my head at the moment. I do not know what that is. But yeah, so you've got image-based. Is there a shader toy for image-based lighting? And then we also want to look at Probably plenty. IBL. Well, this physically based rendering here will have it, obviously, because you can see it in there. This is another one. And the anti-aliasing on that, or the aliasing on that. Ugh. Shade fragment. No, I'm staying home relaxing. Yeah, that's cool. Yeah. You want these balls, eh? I can send you a link. Sample diffuse environment, sample reflected environment. Interesting. So I wonder how complicated some of this is. Use IBL, perpendicular vector, cross product, result, cube map samples, random direction. And there's a weight, sample, sample, sample. This is not too complicated. But I wonder how good it is though. Like, that's... But then when you see this one, it's just doing it once, and this one looks pretty decent. I don't know. Oh, I know why. Because there's two. They've already... This is just a texture. A texture. This one has the... It has two versions. Right. And I guess there's a third version. Yes, it samples 3 times. And then it will lap between those. This one does it a different way, fair play. This one doesn't use spherical harmonics, maybe? What's random direction do? Is it like some noise-based thing? What crap is that made? Oh, here it is. Random float. Right. Yeah. So the thing is, we also need a texture as well. We can always just get one and upload it. I don't know if I've done a cube map in the... There was that GP Gems article on it I've looked at before. Is EVMap even needed for ray traced graphics? So it depends, right? Because like ray tracing, like if you don't have global, wait a minute. The cube map is an optimization, basically. So you have your sphere or whatever, you ray trace. You know, ray tracing technically is you shoot a ray, you hit a surface, and maybe you'll shoot like another ray to check if it's in shadow or if it's in light. you're not necessarily doing like path tracing, where you're going to keep tracing more paths around the scene and evaluating those as well. You're just going to do it around one, which you're going to, from the camera. So having the environment map is an optimization so you don't have to have stuff far away from my understanding. So if you miss, there's a sphere there, sphere here, and you miss, so then you sample the environment map, which is just at the edge of the, which is infinitely far away or whatever, but in that direction. Yeah. That's my understanding about it, at least. Yeah. So essentially you can see it as the sky color. So I'm learning OpenGL starting with ray tracing. Render is starting. Starting ray tracing render is a starting point. Yeah, I don't know. Have you done a software renderer? Like software rasterizer. Have you done one of those? Yeah, this is beginner stuff. So the good thing about doing this, wait, ain't it? So triangle rasterizer. Yeah, something like this. So you follow this tutorial, you'll learn how to make your own triangle rasterizer, and you can render it out using to an image and just write an image file out, like a PNG or something. That's very easy to do. You don't have to get a window, then upload your texture to the GPU or try and use the OS APIs to blit it to the screen. But you can learn about what it's like to rasterize a triangle in software. This will teach you how OpenGL and Vulkan kind of, or what stuff they do for you, right? And so I recommend I won't say you need to, but this is the way I would recommend learning it, because OpenGL, the API kind of sucks, but okay, it's good at doing stuff quickly, but in terms of knowing what goes on under the hood, it doesn't really expose that. So learning what goes on under the hood is a lot of theory, whereas this kind of gives you a way to practically do that theory, Wait, what? This ain't what I'm going to be talking about. But yeah, but effectively where you can take this, I'll link this one as well. So basically, there's this person who watches the stream as well. I mentioned he should do this, and he went and took it to like a whole new level, and is basically made he wanted to learn how the Vulkan API worked, and decided to try and do his own little Vulkan to sort of a very simpler version of the Vulkan API. But it then software rasterized everything. He's got shaders, CPU side shaders, vertex shaders, pixel shaders, and all sorts. And it's even got a little wrapper where it helps you open up a window to do some software rasterization on Windows. But I recommend starting with the image because the image is really easy to do. But I'll link this though if you want to look at that and learn from that as well, because it's actually not that hard when you just sort of take it piece by piece and understand the theory. Like all in all, this is not really that big of a project. Like it's actually like far less than probably any OpenGL project you'll make. It's 1,000 lines, right? And it's got a triangle rasterizer in software, pixel shaders, vertex shaders, and it's even used it to make these models here with some PBR probably, because look, right? So yeah, that's where I recommend starting, because you already get an understanding of what this like OpenGL is hiding from you. Yeah, so it sounds complicated, but when you sort of like understand, it's actually quite simple. But yeah, start there and then do OpenGL. Yeah, so the biggest problem with GPU programming is that it's not on the CPU, because it's basically another computer you're interfacing with. That's one of the biggest problems with GPU programming. So when you have it all on the same PC, it's actually like a lot simpler to work with. Right, so image baseline. Right, is there anything? Vertex shaders, compute world baseline coordinates. Right, so they're reflecting in the vertex shader, then I guess normalizing. To light space if your application is willing. The reflection vector expressed in light space starting from. Yeah, I'm not interested in setting up the vector. I can do that anyway. So to normalize the input, right, they've also got this tangent and binormal, which I'm not quite sure what that is. Bumps. There's a normal map, right, to add some offset to that normal, I guess. Cool. Then is that that's the Fresnel, isn't it? Fresnel, interesting. Okay, so they put the Fresnel in there. Then I guess they use the cube map. Yeah, eventually they use the cube map. Right, this doesn't look too difficult thinking about it. So should we just get the cube map, like a cube map? Should we look for some form of like the free cube maps that are sort of like maybe we say environment map. So is this like a spherical? No, it isn't. I guess they've just. Yeah, I wonder how you. But say if I click on that one, that's a big image. The problem is I don't really care about the quality too much. Maybe I just use a simple cube map for now. Right, let's just do some like simple one that's probably really to use. There's this Learn OpenGL one, but it's got text on it. Hey Glorissa, how you doing? Welcome back. Welcome back. How you been? Um, this is just on some random website. Hmm. Okay. Right. This ought to be good enough. Right. This is cool. So, where's something? Right. This is really nice. Do you get these green fields? It's obviously not what we want in the long term, but as some temporary sort of thing, it seems like it will definitely do. The ground. It's quite bright, and it's got some. Yeah, it's got some daytime. Yeah, I've seen this guy, Humus. I've seen some of his stuff that he's got. He's got some. I think he's had some one or two articles I've looked at, and they were quite decent. Yeah, I think it was practical cluster shading I saw. By the way, I got some people that are annoyed to pronounce my nick. They're annoyed to pronounce my nickname. So you'd like to call. So you can call me Michael. That's cool. I might call you Michael, but I'll probably forget. Not gonna lie, I'm really bad with names. Like, it's so embarrassing because I basically never call anyone by their name. I just start a conversation with someone and hope they know I'm talking to them. So I won't even catch someone's name for the first like few weeks of me knowing them. Um, but yeah, I think I quite like your name, your chat name though. Why do people get annoyed at that? It's amazing. It's glorious and sir. Is it because it's like gendered or something? Yeah, it's a real image. Yeah, yeah, next gen rendering. This is how you tell this guy is a professional. Like knows what he's talking about. It's just got a sort of old style theme website, you know? Maybe we'll get this dark one as well. But is the dark one ready? I guess it's got these elements of it, right? And maybe that could be helpful. Let's get. Oh, ooh. Yeah, I think we want to try a night and day one. I might be an idiot by saying that, but we'll figure out, right? So let's go into downloads. Get in there. Get that one. Eh. Right. So we've got the bells and whistles here. Are these right? All different JPEGs. Interesting. So what we can do is drop those boys and girls in there. So we'll call them cube maps or environment maps. I don't know how good these are. What's the license? Creative Commons, whatever that means. Licenses. Creative Commons is pretty good, right? Number 3 though. Yeah, we won't be shipping with this, so it won't be a problem. We'll put the license in there as well. Yeah, be a good citizen. There's one cube map, and we've got the other one as well. So we'll call this one Yokohama Yokohama 2, I guess. No. No spaces, they're illegal. Move. Next one is, oh, Yokohama 3, right. Yokohama grass. Yokohama day, I guess. Yokohama night. Fine. Right, that's pretty cool. I'm happy about that find. So what we're going to do is we're going to import these. Sweet, look at that. Oh. Right. Yeah, spaces are bad. Especially in file names. When you see spaces, I'm like, cringe. How does this image help us? Well, for metalness, you only see specular light reflected. And I think we need to somehow get more lights. It doesn't reflect any diffuse light. So you need some, when you have an environment, you can kind of get specular from all around, I think. So you'll see the reflection of the environment map in the material itself, I think. I think I'm saying it right. Actually, that was pretty bad. Wasted 4 hours in queue to hand in a stupid Android. Okay. Written in Dart for uni. In Dart, that's extravagant. How are things going for me? Yeah, things are pretty good. Yesterday was quite a lot. I had to drop the baby off, pick him up a few times because he had a trial period in nursery. But yeah, that all went well. And I was just all around busy all day, and all work was kind of long in a few meetings. But today was really good. A really good day today. Lots of work done today, very successful. Sometimes I forget the names of co-workers due to them not using them for so long, despite working in the same room. Oh wait, you just like chuck a pen. Screw off a bit of paper. Can't say I'm good with names too. I have a friend who just knows. I have a friend that knows every movie actor in the world. It's insane. Probably reads the subtitles and goes on like IMDb and all that jazz in it. Righty, oh, so environment maps. Let's record a thingy. Right, so in order to get some better looking metals, you know, we would like to see. Oh, it is. Right, so in order to get some better looking metals, I think we need an environment map. And these examples will use that. So I've seen another one here as well. This uses an environment map to see the metals really pop. So I've just done some quick looking around on the internet, come across this website here, Hermes. He's got some great articles as well. You should check those out. But he's also got some cube maps here. So I've got one night one day one, and we're going to get those into the game now. And then we'll go from there. Yeah. Cool. So how does one get cube maps in game? Can I take a look at the GPU? Do we have texture cube? We don't even have a texture cube. We're all 2D array though. So I don't even know how you upload to a texture cube in Vulkan. Because I imagine it's like a 2D array of 6. Yeah, it is. It must be. Vulkan texture cube, or image cube, as they call it. Right. Utilities, copy memory. Ah, my boy and girls. C++. Right, copy and staging buffer each 6 sides. Right, so what sides go first? Front, back, up, down, right, left. Awesome, easy peasy. Right, we got this. Yeah, I think we're hopefully doing it today. I don't even know how good of a version it's going to be, but yeah. Hey, Illusion Man, welcome. Okay, so just realizing the GPU abstraction, we don't actually have a texture cube, so we're quickly going to jam that thing in now. You also have texture cube arrays as well. We don't need the array yet, so let's just do the cube. So we need to find all the places right, so shader h. Oh, so this is if we're viewing the right, it could be a 2D array. I reckon if we do a texture cube, it should be able to be a 2D array. I've just got to tell Vulkan that. Yeah, but if you sample it, yeah, I don't even know, because the descriptor could be a different one, and it's driver dependent. But it's just for debugging, so maybe that'll be fine on my PC, and that's good enough. GPU .c right. So texture cube is like in a 2D array, basically. Okay, that's good. I think GPU's all sorted out. So wait. When you do a texture in it, we need to say if you need to say your format is, so your array layers, it cannot be 0, right? So your array layers must be 6. No, we'll just ignore the array layers. If type equal GPU resource type texture cube, then array layers equals 6. Let's do that. Well, it can't be 0. No, we'll just make it 6. Fine. So not equal texture cube or array layers equals 6. Something like that. Right, so now into the Vulkan backend. And when we create the texture, we obviously have to replace, we have to add texture cube. So that's just a 2D image. But then when you make it into an image view, that's when you're like, oh, by the way, it's actually a 2D, sorry, a cube. Yeah, over there, good. So I think that's it. So we can test all that now. So basically we want to add an environment map. So that would just be as simple as environment map, texture, cube, sample format. Wait, no, storage format. You never store it, it's always sampling. That's going to be 8 RGB norm. Dimensions? Good point. What are the dimensions? Sweet. Yeah, looking forward to it's going to really make the rendering just look far better. Which is good because we've gone through a long R&D phase of just how we're going to render spheres. So it's good just to make stuff look nice, considering we've had such a long time of just trying to put stuff on the screen in a good way. So what resolution are those at? Good old why are they JPEGs? It's just, I guess I'll take them with a camera, but still, JPEGs are annoying. We got a actually no, we got STB image that does decode JPEGs. What am I trying to figure out here? Yeah, the resolution. 2K. So I think the way one does this will figure out the Vulkan validation errors mess me up. Right, so speed that up. Okay, Vulkan validation errors don't like it. Oh no, I didn't put 6 in. I think that's right. Validation errors. Let's go. Ah, 13 minutes later. Finally, image create info must be created with compatible. Right. Fair play. Thank you, Vulkan validation layers. Oh. The stream doesn't get down anymore. Well, if the Vulkan validation errors catch something, no. But when there's a shader running and the shader indexes out of bounds in an array, sometimes it will bring down the whole stream. Oh no, we got another one. Yeah, or if you have an infinite loop in a shader, then the GPU is just like, I've given all of my resources to this one shader that's running in many infinite loops, so nothing else can run. And yeah. And it just keeps going. And then eventually it times out, and then the desktop has just died then. The reason why it takes so long is because for every single line in here, you will love this one. You'll love this one, Clarissa. Every line in here does an addressed to line, ADDR2 line, right? Now, watch how long it takes to do one of these. Now, watch when I... How do you do ls? Yeah. Guess how big this file is? Half a gigabyte. So basically it's scanning through the whole half a gigabyte file. Or maybe loading the whole thing into memory. I don't know how the system works. But it does that as many times as we've got stack entries here. And obviously, as you saw, it took like a couple of seconds just for one. So that's why times that by 5, it's at 10 seconds. It's insane. I don't know if there is probably another way to do this. But that will probably involve linking against some other... Yeah. Like, it's not like Windows where you can just start going into the debug information, I think. That's the way the Windows one works. It's a bit harder on Linux to do that. Yeah. What? Must be greater than or equal to 6. Why is the... What? I had that... There's the array layers. What is going on? It's equal to 6. I'm doing something completely dumb here. Info array layers equals 1 and is less than 6. If you got the texture cube thing, it must be equal to 6. Right? Or a multiple of 6 really, but we're not doing cube arrays. So what? Put a breakpoint in there. Sometimes it takes a bit to initialize Vulkan in the debugger for some reason. Oh yeah, when you've got a breakpoint on, it takes time. It's slower, isn't it? I think. I don't know. It's just slow when you run in a debugger for some reason. Oh, well, the validation error, what? Oh, sorry, okay. I've just put cube compatible on like a Wally. For everything. That's the issue. It's me being completely dumb. If resource type is equal to resource type cube, then create information dot flags or equal that. Right. That's the correct way. For me, the SO file is only 19 megabytes and debug symbol is 200. Why is yours smaller? There we go, working now. Yay! So we got the cube map loaded up. Well, we've got the cube map initialized, we just got to upload to it. So we can do that here. and we found out exactly how. So do we just load both of them? Okay, let's just load one of them. We can always do the night one in a minute. So STB yeah. I got this. So I'm gonna make that lovely array. Slices or layers, whatever you want to call it, I don't know. Words. So according to this Vulkan tutorial, front, back, up, down, left, right. Yeah, it's like a cheat code on the Sega. So front is pos Z, right? I think this guy's sensible, right? He's done them in a sensible way. Yeah, he's got positive Y is up, and positive Z is forward. I think he's a sensible man. Except for he's using JPEGs, but regardless. Right. Front, back, up, down, left, right, I think. Or is it right, left? Right, left. Excellent. X's. Cool. So we can go over all of those. IDX 0, array count for slices. Cool. So we get the image data, that's some UA thingy majig. Then we want to load this. So I guess we'll just do assets. Wait a minute. Char path sn printer path size of path assets ev maps environment maps Yaka or Yoka? Yeah, Yoko Hammer Day S. Perfect. So you see slices index. Rightio. So replace that with path. And yeah, we want to get the width, height, and components. Those will come out. And it should be just as simple as uploading. We should probably put a surgeon in there quick. Just say, well, the width and height is 2K. And I think it's as easy as this. Environment map, offset, size, mid level array layer. So array layer needs to be index. Yeah, I think that's right. We'll check the other. Then we upload the full thing, and voila. So I think that's right. We should be able to check that in the image viewer or text viewer that we want built into the game. In case it gets too annoying, could you print the validation error before spending time? Oh, yeah, I forgot about that. Well, I forgot it was ordered in that way. That's a good point. Where's the Vulkan thing again? If we look for stack trace, we'll find it. Right. So what you're saying is, right, this is a good idea. Yeah, I'll do printing stack trace dot to dot still. We'll remove the stack trace from here. We'll put down 2 new lines. And then we need an F. Oh, for crying out loud. Yeah, I haven't got proper file abstraction yet. I guess you can compile a different thing. Yeah, that works. Oh, this is completely disabled, is it? Alright, print it out to the uh, yeah, that'll be better, wouldn't it? What's going on? Wait, I deleted the line. Where did it go? Yeah, but it needs to go out to printf instead. Sweet, that'll work. So you used to, okay, so you do an optimized build. It's an optimized build, your one? But why isn't mine an optimized build? It must be. Mine comes from the distro, right? It should be optimized. Or do they do it so you can debug it? It's weird. So where's a time when we... Right, so let's trigger the error again manually. Okay, let's put this at like let's put in 0 array layers. Worked apparently. Right. Yeah. Excellent. That works. Thank you so much for that improvement. That's good. So we can actually see that now. Thank you. So, right, I think we're actually uploading these. It seems like it's not complaining. Let's look in the texture viewer. Although, the texture viewer wouldn't be supporting the array. Oh, no, it should do. Oh. Huh? Okay. I don't know why it's complaining now, but we need a bigger upload buffer. Where's my upload? Main. Wait, how does one choose the size of their upload buffer? Is that built into the internals? I am confused. Yeah, it's all done manually in the back end. Maybe not a good idea. But anyway, where's the size? Oh, here. Excuse me. Right, the size is 64 meg. I guess we can do 128. It doesn't really matter. Let's do half a gig. What I might do. So I've got 2K squared times 4 bytes per pixel. Then we got 6 of those. So that was already 100 meg. So let's do, yeah. There's obviously ways to improve this later. You can stream, right? Do texture streaming. But for now, this will work fine. I know, right? Yeah. Weird. Strange. Okay. This code is ugly. Fine. That's cool. Yeah, parts of it are ugly. Parts of it's demo. Other parts are a lot cleaner. And other parts might be a different style to what you like. It does take about a second to open now to upload those environment maps. But if we dig into the thing, let's see a texture. And what about the layers? So I have to type it in. We can go through them all, isn't that good? So we got environment maps there now. So that's cool, it works. Yeah, sort of the UI colors. We just went for a black and white theme. Right, so if we take the black levels up, what you see is the sky is actually really bright. The sky is super bright. So maybe we can leverage that. Look, it's near. I don't know if these are sRGB or linear, actually, some of these sliders, but yeah, you see the sky is super bright. So that should play into helping these things pop off, hopefully. Right, let's do a take on that. Let's yeah. We'll show the code second. Always show code second. Right, so we've taken those cube maps, initialized the texture, and uploaded those cube maps to it. So, you know, as to take in, that's a weird way to describe it. Classic me. Right, so we created the cube map texture, and now we have uploaded those cube maps to it. So inside the texture viewer, we can see by changing this array layer that we have 5 different sides to this cube. So now we're going to wire this thing up in the shader and try and use it in some environment maps. So we're going to try and see what that code looks like. But let's just quickly see what the code is to upload. Bum, 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 bum. So yeah, basically I've just got the slices here in an array. So front, back, up, down, left, sorry, right, left. And that's the order it needs to be in for your cube map. And then essentially you go over all the slices and load them one by one, use an STB image, and then just uploading it to each slice manually. So yeah. There we go. I don't know what's happening, it looks cool. Oh, I don't understand the thing. That's cool. smprintf is built in. It's a safe version of sprintf. You know, it stops you from sprinting and this makes it a bit safer. It puts the size in so it stops you from overflowing the buffer. So I guess if you're a zoomer, you can use this one, but if you're a millennial, you should probably use the SN_printf. Bit safer. So how do we cube map? You're a GC person. What's GC? So looking at this GPU gems, right? They're using, right, let's work backwards from what we know. We end up sampling from a cube map in a direction. That's how with cube maps, right, in the shader, you have basically it's an infinitely large cube, and you could be like anywhere, what's the way of saying this? Anywhere in the scene. You could be anywhere in the scene and your point is always going to be from here. And whatever your direction is, that's what you get. So you could be anywhere in the scene and your point is always going to be here, and you basically just use the direction. I think you can do a bit of maths to sort of like move within the cube map by sort of changing your direction based on how much you've moved. So if you move here, what's the way of doing it? Yeah, I think you could basically simulate moving in cube maps, but your position is always from here when you sample. So, yeah, and you get this pick swap here. So basically that's a vector going into there, right? There's the Fresnel. So it's using the Fresnel. So Fresnel basically says how much of this direction contributes to the is that right? I forgot the way this video described it. It described it well. I felt smart after watching it, and then I lost it all. It's going to be quiet, I'm sorry. Anyway, I don't know, I can't find it. Garbage collected languages, ugh. So now it's time to use EV maps in the BDRF. Yeah. In the bidirectional, whatever you call it, radiance distribution function, I think. That's what it is. I think at least. So looking at some code. So we've done the Fresnel already. Right, where's Fresnel? Or Fresnel, if you want to not respect the person, place of origin. Fresnel. So it's based on the VD. The VD is V says view MB. What's MB again? Yes, that's the normal. The normal, and then the V is the lighting I vector. So I guess it's in lights, whatever light space means. Got to figure that one out. But yeah, so we've already done this, I think. So that's basically the camera, vector towards the camera, and then the surface normal is NU. So we've already got that, right? So we've already got this basically in the PBR. So basically we've got to produce the reflect between, or what's VB? Oh, VB is plus some bumps. And the bumpiness comes from a normal map. We don't have a normal map. But we could always add one. That's interesting. Something to keep note of. Our spheres are perfectly smooth. Well, there is a bit of roughness. But that's... Yeah. So... Reflect. What is reflect doing again? That's we've already got that. That's the half vector, isn't it? Yes, normalize. Let me draw it out. So this one's saying you got your sphere, you got your camera, bit of an old camera, or your eye. You shoot your ray, your light over here or something. And your array for some reason. So you got your surface normal. Reflect. So you're saying reflect. So we'll go that way. That's what reflect does. Right. Yeah, we need to reflect. Wait, no we don't. Yeah, I think we need to reflect. Right, so after you do that, you do the Fresnel on that. Yeah, you need to reflect. So what is this? Now we intersect reflect with a sphere radius of 1 for some reason. Times the dot of that. Discriminant has intersected. Yes, it's in a sphere verse. Why a sphere? Yeah, definitely that reflect. But why this sphere thing? If you intersect the sphere, now we intersect. Yes, the surface color, the reflected color is something that comes in somewhere at least. But yeah, why? So if it intersects, then you sample. Sample T-near reflect vector. Determine where on the unit sphere reflect intersects. I don't understand why you do. Like, what is the sphere representing? Because in this image they're using, it is just like, is it the environment as a whole? Like, you're checking if it will intersect with the environment, but of course it would, so it wouldn't be that, will it? Oh, right, this is doing the moving problem. Localized reflections. So you could do moving around the room. Right, I see. So this is doing that moving around the room thing. Okay, we're not going to do that. But that's interesting to know. It's only very... It could be quite simple to add on. You just do a unit sphere thing. Right, okay. So it seems like we could break it down. So let's get in the basics. Let's just put it in here. We can move it around. We'll get something called the reflect color. So I'll work that one out. But first of all, we need the reflective vector, reflect direction. So I think I've got this thing called reflect. If we just find in my built-in maths functions, I think I have reflect. Yeah. So you can reflect a vector 3. So given the surface normal, the view, not view direction, we're on the ray, the direction of the ray, so it's negate view direction and surface normal. So now we've got the reflected vector, and now let's try and do that sort of like cube sample. Gotta find that one. Hey Zakazaka, how important is it to understanding matrix maths and other maths in graphics programming in your opinion? Did you study or learn, just learn by making projects? Yeah, so I definitely learned it as I went along when I went to solve a problem. But the main thing you need to know is how to use them first. Like, what is a dot product? Where is it useful in game development? And then what is a matrix? How to use it? And after that, after you know how to use it and you practice using it, you might then have a feeling to be like, how do these things actually work though? And then you can dig into it slowly and get more and more familiar with what they do. Because the dot product has some interesting things about it. Like if both vectors are normalized, it gives you the cosine, the angle of cosine. Yeah, the cosine of the angle, which would be quite useful. Yeah, it's got a few ways of being used. It's quite interesting. And then with a matrix, learning what do all those 16 floats do, and how you can just get away with 12 floats, right? And why you can get away with 12 floats. Yeah. I would say you don't have to know all the theory before you go and do something practical. You can always do the practical thing first and learn the theory along with it, and then come back to theory when you want have a bit more of a grounded understanding in like grounded. What's the word? An intuition with how the things work, but not necessarily a thorough understanding of it, if you will. That's always a good approach, in my opinion. So I'm looking for the texture intrinsics. So we want to sample texture cube. Past Henry has done it. Right, so I want this one. I need a sampler. Do I have a sampler? Not at the moment. So unfortunately I got manually passed in samplers, and but they're in the code base. So we're not completely buggered. But yeah, so I need a linear sampler. Wait, do they need samplers? They must do, right? GSL sample cube. Let's make sure I got my intrinsics right. They don't need a sampler. What have I done? They don't need a sampler. It might give me a compile error. You don't need a sampler for text cube. Interesting. No, you no, you do. You do need it. This is a combined texture and sampler thing. HLSL. There is sample function on here. Yeah, sampler goes in. All right. Cool. So I don't know what have I called it? Did I call it sampler state? HTC read only sampler. So sampler. So we need texture. That also needs to be passed in the environment map. Environment map. Cool. Just add more functions, why not? And then the reflect direction. Now I don't know what we do with this. So after we get this color back, should we try and see what other people typically do? Like they're using the Fresnel reflectors to see how much it contributes. And then they're multiplying it with the surface color. I don't know. Wait a minute. Surface color has gone in. We're not seeing how the surface color is being calculated. Let's find then the other example. So here they're doing a few environment map samples. They're confused this overall EV. Then that's being multiplied with the specular. Oh. F. Right. Fresnel term specular color. There's a separate specular color? Oh no, that's probably based on if it's metal or not, isn't it? Yeah, if it's metal or not. If not, I guess that's 2%, isn't it? Interesting. Right, so specular color. For this EV at least. Only goes into the specular there. And they're adding that onto there as well. Okay. So I don't see this going onto. Right, it's just added on. But are these in the Fresnel? So these in roughness to decide on which one. Okay. Right, I see. So you're just adding the color on. You're not really. It's not going as part of this here. I see. So I think we just add it on. So what do we... Should we just add it on to everything? But no. Wait, but what is a diffuse? That's a multiply with the environment map. No. It's only added onto the specular color. Okay. So only specular as a whole gets it. Right, okay, I got it now. So specular as a whole gets... add and reflect color. We've obviously got... It's probably a very basic way of doing it, but it's a good start at least. Do I not have a texture cube one? What's going on here? I've never used it. Oh, sample texture cube. Right, my mistake. You can only sample these guys. Right. Hopefully past me has got me covered here. So... Right. We can XY, we can RGB that at the end. Good old swizzle. Right. So here we need the these boys and girls passed in as well, the sampler and the EV map. Definitely needs a bit of a refactor, but this is okay for now. EV map, sampler. Environment map. And surface color. Right, so wait a minute. I think the samplers are in global. They're globally accessible. So actually they're quite easy to get to, but we still need the sample cube passed into here. Sorry, we can do that. So calculate color. Right, so I'm pretty sure. Let's just remove all that. What we can do is just use global GFX global clamp linear sampler. That should work. Damn it, where's my clamp linear sampler at? Right, the samplers aren't in here. That's a big annoyance. We should put them in here at least. What's going on, right? Let's put it in here. That's a bit silly. If not defined GPU, right, yeah. Yeah, so we can do this, this is good. So it can be shared between CPU and GPU. Pass me go. Right, so we do want to put that in there. Okay, so in the globals, there's a way to do it. Globals. Now I think it's in G. I think it's there. Alright, GGPU. I don't know. How do I even get access to this thing? Right. I think it compiles though. Yeah, it does. Oh no, it doesn't. Huh? Right. So you can't do the explicit MIP outside of pixel shader. Good. I'm glad we got this error in the compiler. That's nice. So we need to use the explicit LOD one, or the explicit MIP. So I forgot what we call it. Is it LOD? Is it called, or MIP? Forget these things. Texture intrinsics. It's not MIP bias. Not MIP gradient. MIP level. Okay. Right, because it's got cube comes toward the end. No. Don't do this to me. Oh. Right, start again. MIP level, texture, here we go. Cube, F32 times 4. Right. Not enough arguments. You need the level 0. So I think that's fine. Cool, so we're not getting the sampler here. We need a way to get it out from the GPU. Damn it. Clamp linear sampler. Because I needed a clamp linear sampler in the, clamp nearest and linear for the texture viewer. So they're in, yeah, kind of built in to the GPU abstraction. But anyway, now it's accessible. Right, I think we're there. G resource. Wait, how do you wait? Resource ID index. That's it. One for the shader. Oh, so wait a minute. If we run this, it could crash the GPU and crash and burn. We need to be careful because we added a. I think this is the one. BC. Right. Environment map texture. And we want to read only from the environment map texture. Right, okay. So I think that's it. The other ones don't get executed. This one does. Alright, so hopefully this doesn't crash and burn the GPU. Let's roll. We're alive! And we have the, it's kind of doing a cube map. It's bloody bright though. As I said, the sky was going to be bright. Turn the light intensity down a bit. That is horrible. Obviously the cube map is clearly wrong. But it is showing up. One, it's upside down. So we do need to flip that. Wait, why aren't we rendering the cube map as well? It's already ground it in there as well. Yeah, they'll be able to see a lot better, I think. We should be able to do that quite easily. Right, if you don't hit anything. Then just sample from the environment map. So here's the ray tracing for every sphere. If you got a final color. Right, so if you didn't get a final color, do final color. And I guess we always write a pixel out. Now, sample from the environment map. How do you do it? You got a ray direction. Plop that in there. And I think it's as easy as that. No RGB on the full RGBA. Let's try that out. Okay. So we're getting an environment map in special places, apparently. Have I got some form of optimization on? And then this is just so weird. If closest hit is infinity. Let's try that first. See if that's a different way of doing it. Same. So what's happening on again? Do we have an optimization? Where we don't render. Yeah, we have an optimization where we early out. Yeah, that's cool. So hopefully if you delete this, it just goes away. All right. Let's try that out. Sweet. So we're getting some background, but the issue is it's in view space. Because I'm turning the camera, it doesn't move. So it needs to be on world space. So to do that, we need to use the view from world or from view matrix to translate us into world space. And I need to use the multiply vector one so it doesn't do the translation. Onto that as well. And then I need to actually plug that into there. There we go. Oh. So as you can tell, there's something wrong with the key map. It seems that it's upside down or something. It opens your front is negative Z because, yeah, maybe it is, or maybe it could be the images are flipped when they shouldn't be. I don't know, because if you flip the Y of those, then maybe that just works. Because the thing is, under my own coordinate system, right? I'm not using any of the Vulkan normalized device coordinate stuff. It's all in compute shaders, so it's all like it's the Henry coordinate system, right? Whatever that one is. Everything's bottom left origin. But we have to use but textures sometimes have to be upside down because they're they were doing it upside down in that example. That's correct. But this is an odd problem as well, isn't it? Wait, I don't know if I should yeah. I want to do a little clip of this. Right, so we've got the environment map uploaded. Oh no, we already had it uploaded in the previous clip. Right, so we've plugged in the environment map into the ray tracer. When we miss, we'll sample from the environment map, and also inside the PBR shader code, we reflect based off the surface normal, and then basically sample there. But as you can tell, things look a bit funky. There's something wrong with like textures being like upside down or something like that, and they're not stitched together nicely. So we're going to investigate that now. But just to show the code quickly, here's the ray tracing code. We go over all the spheres, right, per pixel, and we store out to the depth texture if the hit basically or not. And if we don't hit, we basically translate our ray direction from view space into world space, and then we sample using the cube environment map, using the world space direction. And then inside the PBR shader, all I've done for now in the BRDF is we get the reflect direction by taking the where we're looking at. Wait a minute, is that wrong? The view direction to the camera. Yeah, the view direction from the camera to the surface hit position, reflected by the surface normal. And then we obviously just sample from the environment map, and we just take that and add that to our specular. So I'm not sure how correct this is, but looking around, they do something kind of like this. We'll maybe improve this in the future. Cool. That's a good take. Yeah, it does have the image flip, and I think I have it set to true. So I need to make it set to false. A little global. That's the easiest thing to try. Flip. So we put the flip on for these logo and font textures, and then we turn it off for our screenshots. So I think we want to turn it off here for the environment map as well. It's a global, so anything from now on is not flipped. So let's try that. Right, that is still problematic. It's better, but I've just got the near Yeah, I've got those near and fars and that in a different. Yeah, I guess. Right, so that one needs to be linked with. Uh, I'm confused. So that one there links with this one. Is that right? Which is hard to tell. You can't get closer. Yeah, we could always do that trick if we wanted to. It's a pretty cool trick. Yeah, the order of the images is wrong. But the bottom and top are fine. So, is it a case of reordering the negative and positive? Or is it a case of swapping the X and the Zs? Oh. So the near and far fix the problem. But the issue is that by doing that, it messed up. It's not in sync with the ground or the sky. So I guess I need to do the near and far on the X only, maybe? Right, that fixed that still, but then obviously this is still messed up now. Huh. Maybe these need to be flipped on the Y as well? Or maybe flip those. Flip both of them. But then surely that just produces the same, but the other way around. Yeah. Oh. Do you flip... See, you can flip either one of those. See, I think... Oh, why? This is going to be weird. Prepare for weirdness. What happens if we say, well, if it's equal to 2 or 3? Yeah, I changed... Wait, I can change both X with both Y? But that'll put my X on the top, wouldn't it? It didn't work. Wait, what way am I default looking? Yeah, if I swap my X's with my Y's, it just, Hmm... So do this. So he just puts the sides on the ground, right? That's not what we want. Ooh. Looks like you need a rotation. Putting X, we had Z's or vice versa to accomplish that. Ah, interesting. So maybe there's some negating and... Right. Nearly. So maybe we don't need the negate then. So it's just X, Y, Z. No. Oh yeah, that's right. I was seeing these and I thought they were seams. Yes. Amazing. Right, this looks like horrible PBR though, at the moment. But we're getting there. This is good. Right, so we've got the cube map working, the seams are now gone, they're all uploaded in the right order. It's a bit bright at the moment, so the balls are seeming a bit ugly. So we're going to be looking at the quality of these spheres in a bit. But just to take a look at what the problem was. So the order was actually wrong. They were uploaded slices in due to just the way I do my coordinate system, I guess. It is actually positive x, positive y, and positive z, negative z. And I have to make sure I don't flip the images. But yeah, it'll be different on every system. Or every setup, rather. Okay. Yeah. On every different device, it would be different. No, it's not that. It is in your code base, obviously. Right, so now we've got this in. If I were to do this and then give me a bunch of metal, that doesn't, there's just too much of that in it, you know what I mean? It just, like, one, the roughness is not coming in, doing anything, right? Metal, like, it slightly changes, right? But, so we need to feed it in properly to this. So, right. Right, environment specular color. Evaluate BRDF. Sorry, environment BRDF approximate specular color roughness n.l. That seems like what we need. What is this? Gonna just do the for now though. Right, they're taking this from Unreal Engine or whatever. So when we saw this one uses Fresnel. So why don't we just do the Fresnel on it? We already have all right. Here's the Fresnel. Fresnel. What is it with again? Bit of Fresnel. View dot n. View dot normal. No, can't be that. NB. Oh yeah. No, but where's the one that's reflected? Ah, so the reflected one doesn't go into it. Oh, okay. So we've already done that. Kind of, just where the bumps. So then we just multiply it by KS. So that doesn't So the Fresnel will be kind of, if metal is 0, it's going to be the color will not appear in the Fresnel. But if it is metal, the color will appear in the Fresnel. So yeah, it's just going to be a grayscale if it's plastic or dielectric. Right. And then when you add the metal, you get more of the color. This looks weird. Why is it bluish? Oh, it's bluish because the base color, the albedo. Why is the albedo changing the... Oh, of course, because it's metal. Like, the brighter it is... Yeah, the more of that. Right, I see, I see. I see it a bit. Yeah, something up with our roughness. It's cool, though. But yeah. It's an improvement, but I don't know if it's correct. So... Oh, interesting. So I removed that one. No, shader toy. Don't die on me. Oh no, shader toy down. No, what have I done? Right, okay, I just deleted. Having to add my own to get a similar look or something. But that's cool. But yeah, it's interesting. That's a grey base color, blue base color. So you do see it go on. So maybe we should stick with greys for a bit. Oh, it must have gone down. Yeah, the infrastructure of shader toy has always been a bit like it's running on some like Intel laptop or something, you know, where it takes it kind of do so many requests. This, yeah, but it has got better over the years though. Um, it's got a lot of good content on shader toy. Um, but yeah, the search functionality is really bad. Typically, what I do is I use Google and then write shader toy afterwards, and then you find stuff. The search is definitely not good at. It's not as good as Google, obviously, but by a long shot as well. So should we just work with grey albedo for a minute? Um, let's do a grey 8 or something, just halfway. So you got these grey spheres. So if I were to sort of pause that there, go here, do something like this, and then you know we'll grey there. You know it's picking up the color of the scene, right? This one it seems to pick it up a lot. This metal, that's why, right? See the Fresnel really sort of, is that the Fresnel? Yeah, the Fresnel shows up there. Or did I go to my Fresnel? It's not really doing that. Why is that? Like, because the Fresnel should be, how many lights they got? It's got one light, isn't it? The Fresnel, from my understanding, is that it is based on like towards the edges where the normal is like perpendicular. It will show more. And mine doesn't really do that. So I imagine. Wait, where's their scene? Scene, that function, scene. Right, ring, body. Can I just return the sphere? No, what's the error? Huh? This thing doesn't compile? Oh, I deleted the thing, didn't I? Like a melon. I deleted the shader. Oh, the shader, the texture. Um, right, so just got a sphere. See, the Fresnel is just on the edge, right? Normal distribution function, and then the geometry. So I see mine. My Fresnel's like, hey, look at me, and it's all over the place. Final distribution, pretty good. Geometry, mine's a bit softer, but I guess the roughness here is a little bit. No. Okay. Dielectric, a little bit of roughness. Yeah, they ain't got the bug where it goes to 0, I think. That's cool. Yes, some Fresnel's a bit buggered. Okay, so I've been comparing mine to this example here, and my Fresnel definitely is wrong, because the Fresnel will get, closer to 1 when it's sort of like around, or basically around the edges, and it shouldn't. Wait, what am I trying to say? Yeah, you wouldn't see this, I don't think. You see it there, yeah. Right, so I've been comparing my different view modes with the. Wait a minute. Before I do that take, why is my Fresnel returning? View half. What's the Fresnel on here doing? Uh, V dot H. Wait, but we're doing Fresnel twice in ours. we're doing it here for the KS. And then KD on the Lambert. Where's the Lambert in here? The diffuse color. It's just base color. They're not doing Lambert, which is divide by pi. Wait. You know, they're not doing the divide by pi in this one. Interesting. Maybe they're doing it elsewhere, the divide by pi? I don't know. But yeah, so they're not doing the Fresnel here to work out the KD used for that Lambert thing, right? Half direction. Yeah, so doing the right vectors, right? The view dot the half vector. And they haven't got F0 in here? Is that implicit? So I think it's a similar thing, right? The -1. Specular color. Yeah, so the specular color is the F0, basically. Yeah. And the specular color is probably calculated in a very similar way to mine. It was metal base color. If not 0.2, yeah, it's very similar to how mine is. Right, I see. Says my just Fresnel function is calculated a bit wrong. I'm gonna put it to the power of 5. Power 5. One take specular. Multiply. And then add. Seems pretty similar. I wonder where the half vector is. They've just normalized it. They've not maxed it. Oh, sorry, they saturate it. Saturate clamps between 0 and 1. Okay. So it looks like a very similar setup, so I don't know why it's different. But anyway, it does look wrong though. Normal distribution, geometry. Our geometry is a bit softer as well. Oh, what is that? EV specular color. They're not returning the proper Fresnel, is it? They're just returning the color. What? So the environment specular color. So I was thinking, is this a Fresnel? Basically. And the answer was yes. Because when I did it on mine, you know, I wondered when I multiplied it with KS, which is the Fresnel here, I wondered, is this a Fresnel? And apparently it is. When we look at that function. Because they're just returning it here. But if we use light F, what happens? That's really different. Hmm. But yeah, it's got a bit of roughness in there as well. It's interesting. So it's a bit different. It also uses roughness too. It's interesting. Yeah, something to seem off with our Fresnel though, at least. Wait a minute, Fresnel. In all distribution Fresnel geometry. Have I got my numbers right? Seems alright. Okay. Definitely looks better though. That does feel kind of plasticky, like the way it is reflecting. And then we make it metal though. Don't know if that looks like metal though, to be fair. Maybe. Make it a bit rougher. And then the roughness doesn't even contribute to the... Yeah, the roughness needs to contribute. It needs to move the normal. Yeah. Alright, let's do another... Okay, so we've made the albedo grey now. So we can tell possibly like if if things look good or not, I think, with this sort of environment map. But something that we did notice is if you go over to the Fresnel here, it doesn't look like a Fresnel because it should have... I don't think you should see the back side of it, basically. You should only see the around the edges or something like that. Should be closer to white. If you take a look here, it kind of does that. It's kind of around the outside, it's kind of a white. So something is off there. And if you see in these videos here, where they show the Fresnel, so the red is a value closer to 1, whereas here's like green is closer to 0. So yeah, the white would be where the red is basically. So something is definitely off. So we need to investigate that problem. Right. So why, like when we looked at the code, it did seem sensible, right? the dot product between the view and half. We subtract 1 from f0, and then to the power of 5, 1 take view dot half vector. And we saw that in the Fresnel here. Shoot. So yeah, add the specular color, that's f0. 1 take f0. Power 1 take. That is it. So could we, is it my f0? My f0 though would just be it's kind of just, well, for plasticky it's kind of can my normals be wrong? The normals are they're fine, they're all in world space, as they should be. Hopefully BRDF. Surface position, world space. Light directions in world space. Cameras in world space. That produce that to view thing. See, I don't think, do we even need the hip position? Yeah, I guess we do it for debugging now. But I guess this is just ray direction. Or the negative ray direction. So we don't really need to do all that again. So when we do the Fresnel, then the reflecting so you got the view direction, which is that way towards the camera. You got the half vector, which is this way. And you're saying if they're perpendicular, like what you want to say is right. The vectors could be wrong then. So when they're perpendicular, so something like that, right? Then that should return basically a brighter color. So how does that work? Well, your n.l, when it's like that, it's 1. Is that right? No, but then it's inverting it the other way around. Let's remove this and see how it plays. It's going to be wrong, but I just want to get a feeling of how it works. Let's go with the Fresnel again. So now it's getting very bright in the direction of the light. I guess something we didn't do is we didn't look around it. Let's go to the Fresnel. Right, okay, so if you've got something that's perpendicular or whatever, you'll get, well, it's clamping it. Sorry, perpendicular would be 0. Yeah, if it's going back on itself as -1. Okay, that would be 0. The dot product between two vectors. So that makes sense if you max it. Right, okay, so then this would end up being, the result of this would be basically 1, or towards 1, the closer it is to the sort of perpendicular. The closer, or the more perpendicular it is. So you see, I wonder if my power function works correctly. Maybe this is the problem. Like, should we try something very simple? What happens if I do that? Change it for now. Still kind of the same. Okay. So it seems like it works. I think I remember seeing output in the Spear V actually. Ow, so yeah, pretty sure it's fine. We bring that down to like 2. We should see a considerable change, maybe. Oh. I don't know. Right, so that'd be a scalar basically on how to multiply this by 1 take f0. So, so my f0 was basically just it was a lerp, wasn't it? Between 0. So basically 4% to the albedo color based on how much metal it is. So because it's plastic or not metal, then it's going to be that number, 0.004. So 0.04 plus whatever this is. So we're getting Is that the wrong way around then? No. What am I looking for? So the red area of the teapot is the only part. What about the yellow part in the middle? Yeah, so basically you're seeing it's a bit white. It gets whiter towards the edge. And for some reason for mine, it looks kind of like that-ish. You see separation between the back and the front. Kind of wrong. So the math seems, it probably seems fine. I'm trying to see what, I'm trying to break down the maths to see what input is maybe causing the problem. I guess we could hard code it. But wait, are these not normalized? That's something to check. Have we normalized these functions? These vectors and stuff. That would be funny. Light direction is normalized. I remember checking that. Yeah, normalize it there. CP side. Right, so that's normalized. The surface normal is not normalized. Wait. No, it would be normalized. After you translate it, right? Let's double check that quickly. Because maybe it's making it contribute more. We're still seeing this. The light is coming from up there. Yeah, I wonder. Or maybe I'm confused about how it's supposed to work. But I'm pretty sure that's how it's supposed to work. It's supposed to be... Because if these two normals line up, the light coming from that way and the surface normal going in the exact same way. Wait, it's the half direction in it, sorry. From the light. So the light is coming from there. And then you got your half direction. So the closer it is to that way, it's going to be basically 0, isn't it? So this is all 0. All of this side is 0. Closer to this side gets to 1. Wait, perpendicularness, which is like that. So yeah, wait. This is 1. Sorry, this is 0. Going towards here being -1. Because it go back on itself. And over here it'd be towards 1. Am I confusing this a bit? Between the view direction and the half direction. If they point the same way, there'll be 1, perpendicular 0. Sorry, point the same way. That's pointing that way like that. This view direction. Yeah, so point the same way, this would be 1, this would be 0, this would be -1. So this is all ignored, anything after here. But the way this works is this maxes out the -1 and then flips that. So this becomes 1, this becomes 0. So the closer it is to being perpendicular, the half vector, right? So the more, right, I got this. So the more, yeah, I see. So the more flat, basically, the light is to the camera. So if the camera's here, and then the light is there, it'll be really good. Okay. Yeah. So it's probably something wrong with these guys, but we're debugging these things, which is the weird part about it. Like we can do this. The view is coming towards me. Oh, I was in an n.l. Do I need to negate the dot? I don't think so. We give it a go, but I don't think that's it. Because the view direction and the half direction point in the same way. Try it though. No, it just looks a bit too... Yeah, I think that's right. But they point the same... Are we doing an n.l on here somewhere? Where we shouldn't be. Now specifically the... See, I wonder what it's like. Should we comment out everything here? And just see this version of the cooked torrents. With the cooked torrents. Okay, that's just specular. Yeah, it's got the same thing, it's got that. Yeah, it's the exact same. Just with the environment map on it. Conceptually, the Fresnel term being dependent on the light position seems sus. A little sus to me. Yeah. Oh wait, no, it's the half direction though. Seems a little sus to you. The original Fong view N, probably more correct. Is probably more correct than the Blin Fong. They're pretty close though, and isn't going to cause the current problem. Yeah. I don't know. The Blin Fong is the normal distribution term though. This is the Fresnel term. It's a different thing. The Fresnel term's to do with how much reflectance from that area contributes to the goes towards the camera, whereas the normal distribution is specifically about the this part, which is the Blin Fong, right? From my understanding. Yeah, change the light position. Good point. Let's do that. It's a good idea. Sensible idea. Let's put one on the X. Yeah, they introduced the half vector, but the half vector is definitely used in the normal distribution as well. Yeah, it did move it, right? It's more diagonal now. Rather than going just along two axes, it goes across all axes. So it is moving. We can just do that on a single axis if you want, just double check it. Yeah, it's moved over that way now. Look at the Fresnel. Yeah. Fresnel's just going across one axis. Okay. Right, so what could it be then? But yeah, so let's see their input. So v.h view half view direction half vector. View direction is negative ray direction, right? That's what we could have just done. We did something really weird. Light direction. Right, I might do something like this. Where's the light direction? Right, okay. Let's take a look at how our half direction has been generated again. You see, add two floats and norm it. It's going the right way though. Should we just try and get the redirection and... Yeah, I think I might be messing this up. Why don't we pass in the ray? Redirection in world space. So redirection in world space goes in here. Let's try that out. Has that changed? No. No, wait. Were they doing this before? Oh, the half vector's changed. Yeah, we didn't, we need to negate the, to negate the... Right. For now. It's still doing it. So we got these debug vectors, right? We can fix the view direction to be in something like one along the X. And just seeing like, you know, how does that one look? Like, how does a half vector look? So it definitely looks alright. So the half vector's green, view vector's red, yellow is the light. So you see the light is up. Am I multiplying the result color by n.l still? Maybe it's outside the BRDF. So we're not seeing... Wait a minute. We calculate by the... Okay. Maybe this is it. Maybe our debug view is wrong. N.L. Where it's specular. So that converts into sRGB. Right, there's an N.L. Wait, what the hell's that geometry? Yeah, I wonder... It could just be the fact that the BRDF... So let's just only put the BRDF in. And then look at the view mode that way. And I guess this could be the issue. Right, so we see it here now. For now, Right, so Fresnel is looking different now. Right, so maybe it's the debug mode that was wrong. Yeah, the flickering's fine. I wonder where the perfect direction is. Oh wait, yeah, we've removed the the light is up there. Here we go. So when we're underneath it, you get more of this. Yeah. Because the light is up there. But like, why is the whole sphere? Like, shouldn't the surface normal play a factor into this? Because why would the whole sphere? I don't know. Where's the Fresnel again? Yeah, you're not supposed to see around the edges, right? Half vector. Hmm. Yeah, I'm a little confused there. So I guess we'll leave it there. But I think we found an issue with just the way we're trying to debug view some of this stuff. So we try and view the geometry. Specular, diffuse for now. Yeah, I wonder whether we should comment some of that. The rest of this n.l maybe. Maybe not though. Hmm. Okay, right, I think I'll leave it there. So next time I guess we're gonna continue on fixing these issues. I think we'll start more with the I think we'll start more on the fact that our environment map doesn't reflect or doesn't change with roughness. So roughness just changes the normal distribution function. So this changes, but the environment map does not. So the reflecting normal needs to be randomized a bit based on the roughness. Something needs to happen. So we can look into that. Thank you. It's not even a game yet. Just a bunch of rendering technology. But yeah, things are definitely looking better though. Getting closer. Looking plasticky. Not so much sure about the metal. But yeah, it's looking plasticky. Zoom. Can I show you my game? It's not really for sale at the moment. But yeah, if you support the channel, you can get access to the source code. That's something that's possible. It's not even a game at the moment. Right, I think that was alright. We got some basic image-based lighting today. That was cool. I wouldn't say it's a complete image-based lighting thing, though, but it's pretty close. Let's find someone to read. So our next be on Sunday at about 6 p.m. GMT +1. Any of people who will follow? Right, I think let's just raid the Rust guy. Right, I'll catch you all in a future one. Thank you so much for coming. And yeah, have a good start to your weekend. I'll see you then. Right, catch you.